So I've been given some radios to work on. This is the first one. Uniden PC78 Elite. I've worked on this one before. It appears that someone has been inside it. Maybe. Yeah, my seal's broken. So someone's been inside this radio and messed around with it, it would seem, because apparently now it doesn't work. The hell is this? Don't remember seeing this before. Maybe someone did that. Anyway, apparently it doesn't receive or something, so I need to look at this one. I've also been given a brand new Cobra 29 Limited Classic or Limited Chrome. That needs conversion. And I've also been given a 29LX HD LE. I wish they put some shorter names on these things. This also needs conversion. So those two are fairly straightforward. And this one here is going to be interesting. I think I might do the straightforward ones first and come on to this one after. So, right, I'll pause this video for now. I'll come back to it. Okay, this is thing unpackaged. One of the issues, well, apparently one of the issues that the original mic that came with one of these radios doesn't work. I'll just open this one up, and that's what's in the box. No microphone, so it could well be this one that doesn't have a working mic. We'll see. I do have some brand new ones that I can use. As you can see, spanking new, brand new. Still got the plastic coating on the crown, you know. So I'll open this beastie up. The signal meters have changed. Interesting. So I'll open this thing up and go from there. Manufactured June 16. Actually, change your mind. I'm not going to open it up yet. I'm going to turn it on first and try it. Some space here. Rubbish laying around over the place. Right, I'm going to turn it on and try first. Something I always like to do, just to validate that the actual thing works before I touch it, just in case there's an issue with it. Generator on. Tangle his wires. Right. Power wire. I'll use my own microphone. I always use my own one because I know what it sounds like. I know if it sounds wrong. Monitoring radio is on, power's on there, voltage is okay. Preset controls, mic, RF gain, delta tune center, talkback, don't want that, swap out, that on that off, scotch down, right. Blue. Okay. Hopefully you can see it okay. Right, I'm on RX, so I need to change this frequency here. Recall. There we go. Oh, that's not too bad. That's set at minus 107 dBm, you can hear it. It's not wonderful, but you can hear it. Okay. Oh, that doesn't feel very nice. Oh, it's one of these new ones. Right. Okay. 40 is not quite so good. Yep. 40 is slightly down sensitivity compared to 1. Not much. Okay. Put this on TX. Really to be the switches not in a good place. You know, TX. Oh look, 3 watts from the factory, and 3 watts again. Frequencies, check that out. It's not going to be perfect because it's only just turned it on. And why don't I have a signal? I counted the wrong one. Channel A. Yeah. Why is that not picking up that RF? It should be picking that RF up just fine. What's going on with this? That's interesting. Well, I've got the wrong cables plugged in the wrong places. That's entirely possible. Let's have a look. There we go. Right. That makes far more sense. I don't know. Right. So that's slightly off frequency. Not much. About 75 Hertz or so. Okay. It seems to at least be working. So let's open it up and show what's inside it. Oh, I hate those things. Another screwdriver. Some cool stuff, don't need that one now. It's probably not particularly exciting watching me open the radio up, but yeah. I'll show you the whole process, I suppose. Well, as much of the process I want to show you anyway. So all I've really got to do with this is just do my conversion unit, the usual thing I usually do. I haven't asked to keep the existing band, so I just got to do a straight conversion, no actual further modification than that. Okay, cover. Put this to one side. Here's the inside. What's the quality like inside here? This has got one of the newer POLs and there's got extra pins on it, which still interests me. They've actually changed the POL slightly and it's got extra pins, and it's got 2 more on the end here and they're not used. There's no connections to them, so I'm actually wondering what that's about. It's quite interesting. Bit of bad soldering over here, bit of flux residue. Flux over here. There's a bridge between these tracks here. Right there. What's that? Oh yeah, there's a capacitor across there. So interesting way of doing it. But it's much like most other 29s, and there's a little diode across there. They just changed the manufacturing process very slightly to meet the newer demands. Different switches. I mean, the switches, yeah, even the switches are a bit cheaper. It's been reduced in cost, so the switches aren't as nice. the frame is thinner. The switch is different here. Channel selector, that just feels weak, you know. Anyway, top colour. So yes, there's a different chip, which is longer. It's very interesting. Yeah, I can't really see anything there of concern. Not from this side anyway, so let's pull this wires off this cover. I'm pretty sure you used to have a better speaker in there. It's a 5.5 watt. I thought it used to be a bit more than that. I could be wrong. It's a very small magnet. This makes me wonder slightly. You know, the cheapening everything else. You know, the chassis is thinner, and you know, it's different. They're reducing costs. I mean, it's better to reduce costs and go out of business, I suppose. But you know, it's a shame to see a radio which is so well, you know, been around for so long and so well received by people that they're cheapening up on a design. I can actually see some issues in here. They've got some components which aren't fully in. Just here, there's a capacitor standing right off the board. This one here is standing off quite a bit. Yeah, would have thought that wouldn't be a good thing. Let's get this off here. Just one side. So yeah, there's these parts. So there's a capacitor standing right off the board there. Got a long way. And these have got quite long legs on as well. These two here. So is that one there. Over here, it's not good. Over here, all quite long. It's, you know, when you're dealing with RF stuff, RF leaks and everything, you got to keep everything as short as you can. That's not great in itself, I suppose. Anyway, PCB is a KPC 1116 L2, or was it 1106? 1106 L2. Yeah, sorry, 1106 L2. So 10th of April 2015 design date of that. So yeah, I mean they've cheapened design. There's another long capacitor there. So, you know, that's just not good really. Capacitor branding. Yeah, that's a good question. Looks like different brands in there. And I'm trying to see a name. GD, whoever GD is. And Acon. So yeah, anyway. So you can see that a channel selector looks like now. It's a tiny little switch like this. You know? A rotary encoder. That's what it is now. Because channel selectors are quite expensive, I'd imagine, because you know it's quite a complex little switch and there's a lot to them. So I'd imagine this particular circuit here, the rotary encoder, and there's a little IC on here under the blob, which converts the codes to that chip. And yeah, I'd imagine doing all that is cheaper than the old style channel selector. But yeah, I don't like the longevity prospects of these. So anyway, I'll just stop that now for a second. Anyway, I shall carry on with this and come back. Right, so I've put my little conversion unit in. It's a pretty simple thing, but it's not particularly special. Well, I had to get it made, but that's besides the point. Now, I'm on channel 1 of the new band. I need to measure the voltage of the VCO. Currently it is transmitting on frequency. Transmitter's working, right? So I've tagged the negative probe onto the negative feed into the radio. I need to measure the VCO, which is right there in the R1, is it R91? Get 4.7 volts, which is no good. Right, that's an RX. TX is different. and on channel 40 is 2.4. Right, so this voltage here is actually too high, which means it won't be in lock and receive. TX, it's here drops down 2.4, and TX is working, but receive won't work like that. Okay, so my signal generator is on the right frequency right now, and nothing, right? Because receive isn't working because that VCO is unlocked. Okay, just because the TX light comes on doesn't mean the radio is locked. These Cobra 29s and the variants all have a dual ROM POL, so it actually changes encodes on the ROM internally between transmit and receive, which so changes divide ratios. So because of that, transmit will work and receive won't, and it won't be obvious unless you actually test the VCO voltage to see it's actually too high, in this case anyway. If it's the other way, so the voltage is too low, then transmit may not work but receive will. It's the other way around depending which way the tuning is set up. Okay, so back onto TX. So I need to adjust the VCO, and well, these are messy. Anyway, what I'll just go do here is get the wax out the way of these so I can adjust them. Otherwise you'll end up damaging the cracking the slugs. If you try and adjust it with the wax in the way, you'll just end up cracking it. Yeah, I need to do that as well. I'm not going to show the whole line, I'm just going to show a little bit just to show the VCO adjustment. So you can see what's actually involved in that. Right, here is a ceramic tuning tool. Right, has to be non-conductive, otherwise it affects the tuning. Just stick that on there, stick that into VCO slug, and give it a tweak. Here we go. It's now 2.7. Right, so that'll work. Right, it's a very small adjustment there. It's jumping right up really quickly with a very small adjustment. It means it's very touchy. All right, you need to get it so it's less sensitive, and so the more you turn it, the less it changes by, which is getting around there. Right, so if I go to channel 40, it's 1.8, and in TX it's around a volt. But it needs tuning properly. Anyway, I think that's probably too far the other way. Yeah, so I need to just find out what the limit is. I'll tell you what it is. Okay, I think it's about a volt or so. It's just starting to work. Not quite locked. Now it's locked just on transmit. 1.3 volts. Transmit on channel 40. That's absolute limit. So I'm going to set that slightly high. You always have to give things a bit of a window, so when you get a variance with temperature and that sort of thing, it still works okay. So that's 1.5 volts right now. Yeah, 2.1 there is fine. So I can probably go a little bit further actually. There you go. Let's go 2.3. I think there it starts to get a bit faster. So 2.3 volts there on RX, which gives us 1.8 volts on TX, which is a nice window, both ends of the scale on transmit receive. And that means that it won't stop working when it gets cold or hot, because it's got enough of a window at each end of the scale on each channel on either transmit or receive in order to keep working. Right. So I'm not going to show any more of the alignment. I just wanted to show the VCO part, and I'll go through and do the rest, and I might actually fire up the spectrum analyzer and show you how it looks on that, and maybe play around with the 54 megahertz, well 53 megahertz for New Zealand channels trap to try and show you how the harmonics stuff look on the display there. Right, so I'll stop for now. Well, I was going to do two measurements here. I'm going to do it in separate video sections. I've got the scope set up here. It's sensing the RF from the radio, and I was going to show you the modulation pattern you should see. Right. So there you go. Right. That's a nice clean modulation pattern. Yeah, ignore the triggering. Triggering is not very helpful right now. Yeah, it's going to be a pain, isn't it? Triggering is a pain, sometimes it just doesn't trigger right. So anyway, there's a nice modulation pattern. You can see basically a sine wave on the top and on the bottom. There's no flatting on the top and bottom or in the center, right? That's with the factory AMC setting. I haven't adjusted the AMC at all. This is on 26.3 megahertz or 330 megahertz. I haven't even finished doing the TX alarm. I've still got to do this bit yet. I've adjusted this one here slightly to get the wattage on the using channels. I also want to show you what that should look like. Okay. The next thing I'll do. So I've done not to leave it transmitting for too long. Let's do the same thing over here. Let's make sure it works for it. Say, hey, look at this. So over here somewhere, when I find it, is my Boonton modulation meter. You can see that showing around 94% modulation. Right, so again, that agrees it's not over modulating. Okay, so I can rely on this or the scope to do those measurements. Alright, so there's that there, and there's the scope, although not triggering properly. So yeah, what I'll show you next is the 54 megahertz, well 53 megahertz thing on the spectrum analyzer. Okay, I got my scope set up, well, sorry, my spectrum analyzer set up to see the 53 megahertz frequency there. Okay, so this is on transmit with no audio right now. Okay, audio's turned off, although I could turn it back on, but let's see what happens when I turn it on actually. Right. So turn it off because it's annoying. So that's the frequency which shouldn't be getting generated. All right, and this is at the original position as set at the factory. So if I then adjust this track to allow for the new frequency, well, that's seeing it was at minus 68, I think it was, minus 67 dBm. All right, now I can turn this down. You should try and get this as low as possible. So that's at minus 79 dBm now. All right. If I go a bit further the other way, maybe that'll do better. No. So that's as good as I'm going to get. It's minus 79 dBm on that trap circuit there. We're using the adjustment only. And if I squash the coil together a little bit in that circuit there, because it's spread open, I'll get down to minus 83. Okay, and that's about as good as I'm going to get, I think, out of that. Although now I've adjusted the coil, let's see if I'm getting a bit lower on that track there. No, about minus 84 dBm, as best as I can get. All right. So some people wind those trap adjustments thinking it's going to increase the TX power. It doesn't. Not it's not on the frequency you want. And that's the current wattage there. So it's not finished tuning yet. It's sitting on bang on 4 watts. Right, so it's going to show you what happens if you incorrectly adjust the AMC. So again, that's reason modulation. There you go. That's cranked right up. Right, see how it's full flat here, flat here, flat here. Heaps of distortion. Okay. heaps of distortion, looks really ugly. And if you come up here and look at the picture analyzer at 54 megahertz, a lot more noise there, much broader, much worse. Turn it down, see that reduces, narrows down, right, all the way up, broader, narrow. Okay, that's on the well, 53 megahertz range. Frequency 26.3. This frequency is not great. Here we go. Oh, that's not one. Come on. Right, so that's with the that's on 26 megahertz there, with the AMC turned right down. Turn it up. See all that noise that appears each side of it, the carrier. Right, some of it's normal, some of it really isn't. So you don't want that because it's spattering, because that's on a span of 50 kilohertz. Right, that's 20 kilohertz span, like that. So you can see that that is one channel down, one channel up, and you see how much power it's got across the whole range. So I'll turn it right down, see it drops right off, right, which is why you mustn't overmodulate the AMC circuit. So if I just set that there, so that's about there, it's maximum. Right, so again, it's still not too bad there. If I look at the Boonton, plug that back in over here. We'll see what that says. So I've got that is based on the scope, which may be a little bit much. Looks like it might be slightly flat. Okay. And if you look at the modulation meter I've got here, 99.5%. So so yeah, that's why you don't go over 100% modulation.